Hello everyone, today let's solve the problem number 2807. Insert greatest common divisors on the linked list, right? So let's see what the question states here. So given a linked list of integers, we have to insert a new node between every pair of adjacent nodes with a value equal to the greatest common divisor GCD of those two nodes, right? So again, given a linked list of integers, what we need to do, we have to insert a new node between every node of adjacent nodes. We have to insert a new node. See here, 18, 6 new node we have inserted. Again, between 6 and 10 we have inserted a new node 2 here. Between 10 and 3 we have inserted a new node 1 here, right? So given the linked list of integers, we have to insert a new node every pair of this one between every pair of adjacent nodes with a value equal to the greatest common divisor GCD of those two nodes. We have to return the modified linked list, right? So this is fine. So let's go with the example. So this one here we have 18, 6, 10, 3, and we have got 18, 6, 6, 2, 10, 1, 3. So the first diagram, so this one here, this one denotes the initial linked list that we have been given, right? So this one will be 18, 6, 10, 3, right? So this is fine. So now basically we have inserted the greatest common divisor of 18 first. So what is the greatest common divisor of 18 and 6? Basically this between 18 and 6, right? So that we have inserted in between. So here this is 6, right? And next we are going with the greatest common divisor between 6 and 10, right? So 6 and 10 is 2 basically. So that we have inserted between 6 and 10, right? So next we have 10 and 3. So what is the greatest common divisor between 10 and 3? So this is 1, right? GCD is 1 for the 10 and 3 basically, right? So we have inserted 1 between 10 and 3, right? So there are no more adjacent this one what do we call nodes left basically. So we will return the linked list. So after returning the linked list, we get the output 18, 6, 6, 2, 10, 1, 3, right? So this is very simple, man. Same goes with the example 2 here. We have only one element, will return the same, right? So see, they have strictly mentioned here in the explanation, the first diagram denotes the initial linked list. This one, this is fine, right? So there are no pairs of adjacent nodes at all, so we'll return the initial linked list itself. So this is one of the cases, right? So this one we need to remember. Now we are done with the question part. They have given us wonderful examples just for the sake of understanding, right? So now let's discuss the approach quickly, followed by the complexities, and then let's write the code, right? So let's consider the same first example, this one, for the approach, right? So this is fine. Now first what we'll do, we will start at the head. So we will be going with the math, right? So this will be going with a simple math basically, with the linked list, right? So we'll be starting at the head basically, right? So this is 18, right? So 18, this one 18, 6 and 10, right? First 3. So this one, sorry, 18, 6, 10, 4 we have, right? 18, 6, 10, 3, right? So this is fine. So nothing but the arrow mark, don't get confused. This is fine. So we will look at the first pair first. This one, first pair, 18 and 6. What is the GCD? 18 and 6. This one is 6 basically. We have already discussed, so I am just repeating the same here. So we have to insert 6 between the this one, right? 18 and 6. So now this becomes 18. So here we will be inserting 6 basically, right? So this becomes 6 here, right? 18, 6, 6 basically. This is fine. Now what we'll do, we have to consider 6 and 10. So this one 6, this 6 and 10, right? So what is the GCD between 6 and 10? Basically it is 2, right? So we have to insert 2 here, right? So we have to insert 2. 6, this one, let me insert 2 here, followed by 10, right? So this one will be 18, 6, 6 basically, 2, we have 2, then 10 and 3, right? So 10 and 3 basically. Now, right? So this is fine. We are left with only one thing, with 2 numbers, right? So we have 10 and 3 left. So here now we have to go with the GCD for number 10 and number 3. What is the GCD? 1, right? So we will be going, we'll be inserting 1 here, 1 between 10 and 3. So now this becomes 18, 6, 6, 2, 10, 1, 3, right? So this is fine. So this is the output that we got, because no more adjacent nodes are left, so we have to return the updated list, right? So here we have got this one as output basically. So this is the output that we got, which is equivalent to the output that they have given for the example 1 within the question, 1866 21013, right? So our approach works absolutely correct. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the approach part, complexities part. So what would be the time complexity here? Time complexity would be big O of n logarithmic this one max value, right? So this one will be logarithmic max value, right? So this is fine, man. This is fine, right? So what will be the space complexity here? Space complexity would be big O of 1. Space complexity would be big of 1. So the time complexity would be big of this one n log max val, and the space complexity would be big of 1. So this is fine. The time complexity and the space complexity for the code that we'll be writing in the future would be this one, big of n log max value and big of 1 respectively. Now as we are completely familiar with the approach and the this one complexities, we are good to write the code. Let's start writing the code. Right, the first thing is we have to start the traversal from the head, right? So we are dealing with a linked list here, so we have to start the traversal from the head. So I'll just go with the list node here. It's been a time that we had solved the problem using the linked list. This is fine. Now let's go with the while loop. So let's traverse till the second last node. So I'll just go with while here. So while current not equal to null, and also next value, nothing but current dot next not equal to null, then what we need to do, we have to traverse till the second last node, right? So then let me go with the GCD value, nothing but we have to compute the GCD of current node and the next node. I can write on this way, GCD val. So this one will be GCD of what we have to pass here, current dot value along with the current dot next dot value. This is fine. Now let's do one thing. We have to create a new node with the GCD. So I'll just go with, for creating the list, this one, a new node with the GCD, I'll just go with new node variable. We have to make use of the list node, right? So we are going with the Java. So this one will be new. So let me go with list node. Let me pass GCD this one val. This is fine. Now let's do one thing. Let's link the new node to the next node. So this one will be new node dot next. This one will be current dot next. This is fine. Yep, this is fine. So we are just linking the new node to the next node. After linking the new node to the next node, what we need to do, we have to link the current node to the new node, right? So to link the current node to the new node, what we have, how can we write this one? Let me assign the current to the new node dot next. This is fine, man. So let's return the modified linked list. So I can just return head. So this is fine, man. Yep. Let's go with the helper function just to calculate the GCD using the Euclidean algorithm. So I'll just go with private GCD, this one int GCD, this one I'll just go with int a comma this one parameter b. So this is fine. Within this GCD helper method, let me go with a while loop. So this one will be while b not equal to 0, this one int temp equals b, right? So this is fine. B equals a modulo b. This is also fine, man. So finally let me assign the a to temp. So this is fine. Let me return a. So this one will be let's return a, right? So this is fine. Let me format the code. Once we are done with the code, let me hit the submit button. So I have hit the submit button directly. We have error. GCD value I have passed here in the line number 8. Where is this one? Yeah, what is the problem here? Cannot find the symbol. I haven't initialized the GCD val. Oh, this one, I'll just make this one capital V here. Let me submit this one again directly. have the wrong answer here. Just give me a second here. So we are going with the list node. Current equals head, this is fine, while current not equal to null and current dot next not equal to null. So in GCD val we are going with GCD of current dot value, current dot next. This is fine, we are just computing the GCD of the current node and the next node right here. This is fine. List node of new node, we are just assigning, we are creating the this one instance of the list node. This one we have just passed the GCD value. This is absolutely correct. We are just creating the new node with GCD here. Now next thing is we are linking the new node to the next node. New node dot next, this one equals current dot next. This is also fair. After that we have to link the current node to the new node, right? Current node to the new node. Oh, I haven't linked the current node to the new node at all. This is just give me a second here. This is, we have linked the current node to the new node as well, right? New node dot next. So this one will be current dot current. Oh, this one has to be, we have to link the current node to the new node, meaning current dot next equals new node, right? So this one I got confused, I believe here. So next what we need to do, we have to move to the next original node, meaning, so I'll just have to go with current equals new node dot next. So this is fine. Now let me hit the submit button direct. Let's wait for some time. Yeah, now we are getting accepted, meaning so means all the test cases, the code works correct for all the test cases, right? So this is fine, man. Yep, I hope the solution part is completely clear. So this was the problem basically. So I got confused here while typing, I believe. So this is fine. Now I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.